Okay, so this video is over topic 1-6, solving equations versus inequalities. Looking at the left side, we have 3x plus 2x plus 6 equals 71. Looking at the right side, we have 3x plus 2x plus 6 is less than or equal to 71. So both of these situations are very similar in nature, with the exception of their signs being different. The great thing about inequalities is that we solve them just like we solve equations. So first thing I'm going to do is solve this equation according to my flow chart. My flow chart says that I have 3x plus 2x because those are like terms on the same side of the equal sign. I will put them together for a total of 5x plus 6. From here, I can box my term and subtract 6 from both sides. So 5x equals 65. And then divide both sides by 5, and x equals 13. So my solution is x equals 13. Remember, in order to check it algebraically, you plug 13 in for x back in the original equation and see if it really does equal 71. Easiest and fastest way to do this is just to plug it into the calculator exactly like you see it on the left side and see if the right side matches. When I do that, I have 3 times 13 plus 2 times 13 plus 6, and it does in fact equal 71. So I have the correct solution. So this is good. I'm going to remind myself here that x does equal 13. To represent this on a number line, if x equals 13, we just have the number 13, and we have one solution. So with equations, we only have one answer that could be x. So x can only be 13 and nothing else. With inequalities, like I said, we solve these the same way. So looking at it here, 5x plus 6 is less than or equal to 71. Subtract 6 from both sides, so 5x equals 65. Divide by 5. Sorry, I lost my sign. With this one, my solution is x is less than or equal to 13. And just a quick trick for you, when you have the symbol like this, it kind of looks like an L for less than. Or you can remember that if you take the letter L and rotate it just a tiny bit, it is now a less than symbol. So my solution is x is less than or equal to -3. In order to check algebraically, I'm going to pick something that is not 13 that is in that solution set. So x is everything less than or equal to 13. Numbers that are less than 13. 12, 11, 10, anything down to 0, any of the negatives. So I'm going to choose the number 12 because 12 is less than 13 and should fulfill the requirements in this inequality. So if I plug in 3 times 12 plus 2 times 12 plus 6, I am looking to see, is that less than or equal to 71. If it is, then I know that my solution set is correct. If not, I either messed up somewhere or I flipped my sign to something funky. So if I plug that in, 3 times 12 plus 2 times 12 plus 6, I get 66. And we know that 66 is in fact less than or equal to 71, so I probably did my solution correctly. Now, on a number line, we have the number 13. I'm going to use a filled-in bubble here because they took the time to write the line. This means is less than or equal to, meaning it could be 13 or could be anything less than 13, but 13 is included. A way I remember it, if they took the time to write the line underneath the inequality, you have to take the time to fill in the bubble. Okay, you could also remember it as they used extra ink here, so you have to use extra ink or lead there. Everything less than 13 is going to go to the left because less than on a number line goes left. So you can remember less than left, greater than has 2 R's and goes to the right. So So some similarities between equations and inequalities. We solve them the same way. We use the exact same order of that flow chart that we talked about. Here. We follow this. Solving equations. This also works for solving inequalities. So the blue sheet that we gave you. Okay, so you solve the same way and you get the same number at the end. Not necessarily the same solution, but the same number. It's 13 for both. So looking at the second problem, I'm going to take this negative 1/2 and distribute. Negative 1/2 times 4x is negative 2x. Negative 1/2 times 2 is negative 1. I'm going to combine my like terms, so 2x minus 1 equals 11. I'm going to add 1 to both sides and divide by 2 on both sides to get x equals 6. Remember that when I check it algebraically, I'm plugging 6 in for x. So anywhere I see an x, I'm plugging it in. And I need to see, does this equal 11? I'm going to plug this into my calculator. Oh, I messed something up. Oh, plus 2 at the end. And this does equal 11. So x equals 6 is my solution. Remember, when I graph it, I do a filled-in bubble at 6. On the left side, remember, we solve the exact same way. So 4x minus 2x minus 1. We just make sure we watch that sign. 2x minus 1. Add 1 to both sides. Divide by 2. So this time my solution is x is greater than 6. To check it algebraically, a number that is greater than 6 would be 7. So I could plug 4 times 7 minus 1/2, 4 times 7 plus 2, and see, is it greater than 11? So I'm going to see if I replace 6 with 7, what happens. I get the number 13. Now we know 13 is greater than 11. So x is greater than 6. So everything greater than 6. Now with this one, because 6 is not included, I have to do an open bubble at 6. And then remember that greater than goes to the right. So some differences between equations and inequalities. You have to be careful about your bubble. I'm going to point to it. I call it a bubble because I don't know what else to call it, your dot. So be careful about your bubble on inequalities. And something that we're not going to hit super hard in this video, but if you divide by a negative with inequalities, you have to flip your sign. So with inequalities, you follow the exact same steps as equations, but you have more that you have to take into consideration, more things that you have to remember. Looking at the last problem, I have 4.8 plus 3.5x minus 8.6 equals negative 8.5x minus 9.8. So the first thing I'm going to do is combine my like terms on this side. So that gives me negative 3.8 plus 3.5x equals negative 8.5x minus 9.8. Now, because I have variables on both sides, I'm going to move my smaller variable. Remember that negatives are smaller than positives. So I go ahead and move this, and I get 12x here. I box my x and move what's outside. Move it by doing the opposite. So 12x equals -6. Divide both sides by 12, and x equals -1/2. Oops, just kidding. To check my answer, I plug back in. And this time I'm going to plug in a right side and a left side, so I'm going to leave them separate rather than set them equal to each other and make sure they equal out to the same thing at the end. So in the blue, 5.8, I'm sorry, 4.8 plus 3.5 times -1/2 minus 8.6 equals -5.55. And then on the other side, -8.5 times -1/2 minus 9.8. Oh. There we go. Sorry, I typed it in wrong. And this also equals -5.55, so I'm good. I graph my solution, -1/2, and I don't draw any arrows. For the inequality, I followed the same steps. So -3.8 plus 3.5x less than -8.5x minus 9.8. Add 8.5x. Wow. So -3.8 plus 12x is less than or equal to -9.8. Add 3.8 to both sides. 12x -6. Divide by 12. And x is less than -1/2. So to check algebraically, I'm going to plug in, let's see, -1, because x is everything less than -1/2. So -1 is less than -1/2. So finishing up, I plug in 4.8 plus 3.5 times -1 minus 8.6. And I need to see if that is less than -8.5 times -1 minus 9.6. 9.8, of course. So 4.8 plus 3.5 times -1 minus 8.6 is -7.3. And then -8.5 times -1 minus 9.8 is -1.3. So I know it looks funky, but the smaller negative is less, I'm sorry, this -7.3 is less than -1.3. It's weird with negatives because it's backwards from what we're used to. So my solution, remember, I don't have the line under the inequality, and it's everything less than -1/2.